Today, we're going to talk about a breakthrough that could seriously change how we work with robots. It's called MolmoAct, and it's a new AI model that teaches robots to think about the world in a way that feels, well, a lot more human, a way that lets you guide it with just a simple drawing. Okay, so check this out. What if telling a robot what to do was as easy as just drawing a line on a screen? I'm not talking about typing out lines of code or messing with some clunky joystick. I mean, literally just sketching the path you want it to follow. It sounds like something out of a sci-fi movie, but it is way closer than you might think. So that's the big question, right? How on earth does a machine take a simple two-dimensional drawing and turn it into a precise three-dimensional action? Well, that's the mystery we're going to unravel in this explainer. And the answer is a new AI model from the Allen Institute for AI, and it's called MolmoAct. It's designed to tackle a really old problem in robotics. And that problem? We call it the brittle robot problem. You see, for years, robots have been amazing at doing the same exact thing over and over in a super predictable setting, like a factory floor. But the second you change things up, move an object just a few inches or change the lighting, they totally fall apart. They're brittle. MolmoAct was built to fix that. Now, to get why MolmoAct is such a big deal, you've first got to understand how things usually work. Most of today's robot AIs are what we call Vision Language Action Models, or VLAs for short. They basically take in what a camera sees, listen to a command like put the cup in the sink, and then map that directly to the robot's motors. See, hear, do. It's a straight shot. But, and this is a big but, that direct approach has a major downside. It basically acts like a black box. The robot does the task, but we have absolutely no clue why it decided to move that way or what its plan even was. This makes them really hard to understand, and it's a huge reason why they have trouble adapting when something unexpected happens. I mean, if you can't see the plan, how are you supposed to fix it when it goes wrong?
And this right here, this is the core innovation. This is the whole dog game. Instead of jumping straight from seeing to doing, MolmoAct sticks this crucial step right in the middle, reasoning. And that's not just a minor tweak, folks. It's a completely different way for the AI to think, moving it from just a knee-jerk reflex to a much more deliberate process.
So what does this reasoning actually look like under the hood? Well, MolmoAct breaks it all down into a very structured three-step process. It's a system that's designed to kind of copy a simplified version of how you or I might do something. You first look and understand the space, then you figure out a plan, and only then do you actually do the thing. It all boils down to these three steps. First, it perceives the world in 3D. Second, it sketches out a plan for itself. And finally, step 3, it executes the action. Let's break down each one.
Okay, step 1. It all starts with seeing the world, but not just like a flat photograph. MolmoAct is actively building a depth map of what it sees, figuring out what's close and what's far away. This 3D spatial understanding is absolutely essential if you actually want to pick things up and move them around in the real world.
Now, step 2. This is where the real magic happens. Before that robot arm moves even a millimeter, the model generates this thing. The researchers call it a visual reasoning trace. Think of it like the robot thinking out loud, but with a picture. It literally sketches out the path it's planning to take. So for the very first time, we can actually see the robot's intentions.
And that brings us to the grand finale, step 3, execution. With a solid 3D grasp of the scene and a clear pre-drawn plan, the robot can now carry out the movement with way more accuracy and reliability. That reasoning step isn't just for looks. It directly makes the final action so much better.
All right, so the whole idea of a robot that thinks before it acts sounds pretty amazing on paper. But does it actually work any better? Let's get to the good stuff, the data, and see how this new approach actually stacks up against the competition. Take a look at this chart. This shows how well these models do on out-of-distribution tasks. Basically, situations they have never, ever seen before. This is the real stress test for a robot's adaptability. And as you can see, MolmoAct's bar is just towering over the other big models like OpenVLA. It's not just a little bit better, it's a massive, massive leap.
Now we can put a number on that leap. The paper quantifies it. MolmoAct shows, on average, a 23.3% improvement in finishing these new tasks compared to the other models. That is a huge gain in generalization, and it really suggests this whole reasoning-first approach makes robots way less fragile.
So what does a 23% improvement actually look like? Well, it translates into better performance on real-world stuff you'd actually want a robot to do. Things like wiping a table, folding a towel, you name it. That ability to reason and plan ahead lets MolmoAct handle these tricky, multi-step jobs much more effectively.
And now, we can finally go back and solve the mystery from the very beginning. How can the robot understand your sketch? It's all because of that three-step process. See, the robot was already making its own little plan, that visual reasoning trace. When you draw a line on the screen, you're not teaching it something new, you're just overriding its plan with your own. The robot then just takes your drawing as the new plan and gets to work. It's really that simple, and that powerful.
So what's the big picture here? What does this all mean for the future? Well, this isn't just about one cool model. MolmoAct really gives us a whole new blueprint for how people and robots can work together in a much more natural, intuitive way. Let's just quickly recap the main advantages. First off, it's explainable. We can actually see the robot's plan, which helps us trust it and figure out what went wrong if it messes up. Second, it's steerable. We can guide it and fix its mistakes in real time, making the whole interaction feel seamless. And finally, and this is a big one, it's open source. The team released everything, which means the entire robotics community can now build on top of this amazing work. The research paper starts with this quote from psychologist Barbara Tversky: "Thinking is embodied, spatial, and outside your head." MolmoAct is a huge step toward making that idea a reality for machines. By teaching a robot not just to act, but to reason about the physical space it's in, to literally create a plan outside its own circuits that we can see and even edit, we're getting one step closer to an intelligence that can finally and safely share our world.